Hello everyone, welcome to STEMming, and today I'm joined by Professor Magdalena Krol from York University in Toronto. So, Professor, for those in the audience who may not know who you are, could you please introduce yourself?
Sure. I'm an associate professor at York University, and my niche or my specialty is in groundwater remediation. So I'm in civil engineering, but I specialize in the environmental engineering sector.
Okay, and how did you get to the position that you are today? What kind of things did you go through in school that inspired you to go into STEM?
Ooh, do you want the short story or the long story?
The long story. We like all the details.
I'm an immigrant to Canada. I came from Poland when I was 8 years old. And I think my first love of STEM, more importantly math, was when I first moved from Poland to Canada. I was 8 years old and I didn't know any English. Started my love of it because it was comforting for me in a time when everything was unknown, like it was a different country, different culture, different languages. Math was sort of a grounding thing for me. It was very comforting, and I think I felt confident, and that's kind of how my love or my comfort in math started. Then moving on, I felt myself drawn to things like the environment. So I was very outdoorsy growing up. I never wanted to be in school. My parents were worried that I wouldn't amount to anything because I always wanted to be outside. Outside was my happy place. So I was always playing outside on the playground. I loved animals. And so that kind of started that kind of environmental part in me. I knew that I was always drawn to that part. And when I started looking at universities and what I was going to do, I actually wanted to be either a park ranger because of the environment, or a vet because of my love of animals. But I also really liked the math and the physics. I kept being good at it in high school, and I always enjoyed it. And so my dad actually introduced me to engineering. He was a physicist, but he wasn't an engineer, but he knew what engineers did, and he knew that kind of engineers bring the theory of math and physics and apply it to different sectors. And I think he saw my abilities in math and also my interest in all these different things, like the environment, and he kind of pointed me to that direction. And so I remember walking through Western University in London, Ontario, and looking at the different departments. And back then we didn't have websites, so it was just kind of walking through the halls, and there was posters and stuff, and I saw a lot of civil engineers working outdoors with their hands and with the elements, and that really appealed to me. And so that's when I decided to go into civil engineering.
And for people that don't know, what is civil engineering?
Civil engineering is very broad. I think when people think civil engineering, they think buildings and they think structures. That's the first thing that comes into mind, structural engineering. And that is a big part of civil engineering, obviously, but it also has other different sectors. There's geotechnical engineering, which is part of civil, and that deals with everything below ground. So when you're putting a structure up, you need to have a foundation or piles, or when you're digging a tunnel through a soil mass, you need to understand how to do that, and that's geotechnical engineering, and that's part of civil. There's also transportation engineering, which is part of civil, and that's dealing with how to plan and design cities, road construction, transportation system, things like that. That's also part of civil engineering. There's environmental engineering or water resources engineering that deals with water. So we have people that specialize in the movement of rivers, for example, or flooding, the effect of flooding on cities. There's environmental engineering, which deals with either wastewater treatment, so how to treat all the waste that people produce. There's groundwater, which is my specialty, so I deal with the water that is beneath our feet, and if it gets contaminated, how do we deal with that? Did I miss anything? Structural, transportation, water resources, environmental. Yeah, I think that's it. So it's a very broad field of civil engineering, but it's looking at how people interact with the environment, urban structures, things like that. That kind of encompasses civil engineering.
So you're saying you have a passion for the environment. What aspect of the environment do you think, like specifically, really drove the passion that you have for the work that you do now?
So I think it stuck a chord in me in third year civil engineering, and fourth year when I took these courses where I learned the physics of water movement through soil and the application of that being to understand how water moves through soil, but also, what happens if, a tanker truck spills over with a bunch of, gasoline or something, and then gets into the soil and then can make its way to our waterways. How do we understand that, and how do we clean it up? And that really appealed to me because it kind of merged physics and math together with the environmental aspects. So it made me feel like, oh, I can use physics and math for a greater good. I know that sounds cheesy, but but it appealed to me that I can use that to try to remediate contaminated places. And I mean, I did that for a while when I worked in Boston as a consulting engineer doing remediation work, and I would go out to these places that looked pristine. They looked beautiful out in the middle of nowhere, and there was an old abandoned propane tank, and it was leaking for years, and you had to go and you had to clean it up. And that appealed to me, to take something that people have destroyed, and to make it clean again. And that appealed to me.
Yeah, that's really cool that you could do that. So you were saying you worked as a consultant. So what was your process from maybe graduating and then going on to, what was that process like?
Yeah, so after my undergrad, here in Canada, we do a 4-year undergrad, bachelor in engineering. And then I did a master's for 2 years. So I did my undergrad and master's at Western University in London, Ontario. And after that, I really wanted to get some work experience. And so I left academia and I traveled to Boston. And yeah, I worked as a remediation engineer for a couple of years, which was really eye-opening because it took all the schooling that I had and applied it to the real world. And I was like, oh, wow, like I'm doing a pump test and I learned this, and, in my, theoretically how to do it, but now I'm actually out there on site doing the pump test, like taking water out of the ground and calculating its flow rate and things like that. And it was really exciting for me. I think it makes me a better teacher because I have the practical side that I've done, so a lot of students are always like, oh, how does this apply in the real world? And I can answer that. So then after I worked for several years, I had my first child. So I took some time off. And then after that, I decided to go back to academia to do my PhD. So I moved back to Canada, to Toronto, and I pursued my PhD at the University of Toronto. And then after that, I did a little bit of postdocing, which is almost like if you're doing like a medicine or something, you do a residency, or if you're a lawyer, you article for a bit. It's sort of like that. So before becoming a professor, a lot of people do a postdoc. So I did that for a couple of years, and then I became a professor at York.
And why did you make that change from industry back to academia?
For several reasons. I think I really enjoyed my time in consulting, and I think it was a really valuable time for me. But I didn't like how I had to jump around from project to project, and that's what you have to do in consulting, right? You never, unless you're working on a really big project, you're always jumping from projects here and there. And I like thinking about things, and I like kind of understanding it, and I felt like I wasn't able to do that. And the other aspect was the lack of flexibility in the consulting world, especially when you're younger and you're starting up. There isn't a lot of flexibility. And then when I had my first child, that sort of made it hard for me to go back and know that I didn't have that flexibility. And whereas when you're doing graduate work, there's a lot of flexibility there, right? You're on your own time. Obviously, there's deadlines you have to meet and things you're TAing and things like that. But in general, there's a lot more flexibility, and that appeals to me as well.
So between like working in industry and then working in academia, what's like a typical day like in your life? I know they would be different, so maybe we could start with industry.
Sure. And when we're talking about academia, I'm assuming we're talking pre-COVID, because now everything's weird and different. So in industry, it was a pretty early start to the day. If I was working in the field, I would have to be on site between 7 and 8 in the morning. And working in the field was great because the time went by so quick, and it was so great being outdoors. I mean, that's the dream of civil engineering, right? Except in the winters, working in the field in the winter. But yeah, so in the field, you'd get there early and you'd set up, and then you'd run whatever you were doing. A lot of times I was sampling groundwater, so I set up all my equipment and I would sample. Sometimes I was working with construction crews, and so you had to, consult with them and discuss what we're going to do for the day. And that was pretty much the whole day. Sometimes you would end, at 2 or something, and then you'd have to go back to the office and bring all the equipment back and write up what you did, and then you go home. If I was working in the office, then you'd come in again, maybe around 8 or 9. A lot of report writing for when you were working in consulting, because you were always working for a client. And so you would write reports for the things that you've done for them, or you'd plan out your next field trip, things like that. So I was a junior engineer, so take that into account, right? Like I wasn't a project manager or anything like that at the time. So I was doing a lot of the grunt work, which is typical for junior engineers, but it was also really, really educational, like getting to know how to actually do these things in the field was really invaluable to me. Now in academia, so pre-COVID,
Yeah, pre-COVID,
my work is kind of divided into 3 things. I teach, I do research, and I do administration. So yeah, so I'd come into the office around 8 or 9 in the morning. If I'm teaching, sometimes I have classes that are taught at 8:30, or sometimes I teach at 10. So I would prep a little bit for the class, and I'd go teach. And then I did a lot of administration stuff. So you're on committees. I actually was the undergraduate program director for a few years. So I would deal with all of the undergraduate issues. And then you meet with grad students. So that's the research aspect. So I have several grad students. So I would meet with them daily or weekly, once a week. And then, then there's other stuff like you have to review papers, or you have to write grants, or write reference letters for your students. So there's things like that.
So a lot of writing.
Or a lot of writing and reading. You're reading articles as well, or you're proofing articles. So yeah, a lot of reading and writing. And then there's the teaching part, which is kind of fun too.
So would you say that's your favorite part of your job?
The thing I love about being a professor is that I never get bored. When I'm teaching, I love it, but then I get really tired of it. It's draining. And so by the time the term comes, I'm ready to have that, to focus on the research. And then when the end of summer comes, I'm really excited to do the teaching again, because I'm tired of the research. I'm tired, you know what I mean? It's like, it's always changing. I'm teaching, and I'm doing research, and so it never gets boring, and you never get sick of it, because you're always switching back and forth. So that's the nice thing about what I do.
So do you feel like you ever get inspired by your students, or like even within your research, do you feel inspired sometimes?
Oh yeah, I'm amazed by the students that are coming in right now, and and the reason for that is I think this generation is much more balanced than we were. They not only have the technical skills, but a lot of them have this drive or this passion to do other stuff. And they're, not all of them, but the ones that I'm inspired by are the ones that are like, they're running the student camps, or they're always asking professors to get involved. They always come by and, and talking to professors to learn more. They're so inquisitive. And I think that's really cool. So yes, definitely I get inspired by those students. And they're so energetic. You get a lot of energy from them, because they're so passionate about what they're doing, and they have so many ideas, and it's great to see.
So with your research, do you collaborate with students as well, or not?
Yeah, so I have graduate students, which are not, the ones that are going through their bachelor. They're either doing their master's or PhD. So I always have graduate students, but we also have a summer research program in York. And so for the summer months, which run from May to August, I typically hire summer students that are undergraduate students. So sometimes, most of the time, there are students from York, but other times they're from other universities. Like right now, I have a student from Queen's, which is a university in Kingston, Ontario. And so they work with me and my grad students for 4 months. Sometimes they're in their lab, sometimes they're working on computer modeling. So we always have them involved in research, and not just me, most professors.
In terms of like projects, what would you say has been the coolest or your most favorite project that you've worked on?
Yeah, so again, I do the groundwater remediation and transport of stuff through groundwater. And so I kind of do various things. I do a lot of computer modeling, and I really enjoy that. So one of the things that I did when I was in my PhD was develop a computer model that deals with the transport of gas through subsurface. And I thought that was really fun for me, because I learned a lot, but then the application of it now, I'm applying it to various things, different remediation technologies for groundwater. And I think that's, I've always enjoyed that. I really like the computer modeling aspect of my work. The other things that I've done is I work with the Nuclear Waste Management Organization here in Canada. And so what this nuclear agency does, and other countries have this similar organizations is they look at what can we do with the spent nuclear fuel that we have. So obviously, a lot of countries use nuclear energy for their energy source, but after a few years, not a few, I think 20 years or something like that, the fuel becomes spent, and you still have the uranium pellets that are radioactive, but they no longer produce the energy that you need. And so you need to do something with those uranium pellets. And so the plan for Canada and most of the countries is to put them in a deep geological repository, which means that you take these pellets and put them deep underground. And so because they're deep underground, you're now in the subsurface, which is my domain. And so I do work for this organization to look at the transport of any corrosive species that could potentially get to these canisters that are holding these pellets. It's a really concrete project, right? If you know, you can see the benefits, you can see the long-term effects of what I'm doing, which I think is really neat.
Or what techniques do you use to do this modeling?
So we use a program called ComSol Multiphysics, a commercial model that a lot of people use for various applications, but in our case, we use it for this application. And I have grad students that input the geometry of the canisters, the geometry of the rock around it. They put in all the different physics. So you have to look at the heat that's being generated by the canister, because when you put it in, it's still radioactive, so it'll generate heat. You have to think about the water coming in from the rock. You have to think about the species being transported. So there's all these different physics that you have to include in the model to get all the different environmental conditions that are that are there underground when those canisters are being placed in there.
And so obviously with the model, you want to start with something simple and go towards something more complex. So how do you kind of make sure that it all makes sense and kind of matches reality? How do you make sure that what values you work out are real too?
That's a great question. And that's a question for any sort of modeling or any sort of work you do. And so we tend to start, simply. We start with you can simplify your problem by reducing the number of dimensions you have. So obviously a real model would have 3 dimensions in the X, Y, and Z. We can start off with a 1D model where it's just transport through one dimension. And then you can, make it more complicated and put it into 2 dimensions, and make it even more complicated and put it into 3 dimensions. But when you go through those steps, there's always validation spots. So you can, when it's in 1 or 2D, there's typically like analytical equations that somebody has come up with, and you can compare your answers or your modeling results to these analytical equations. You can also do experiments. So we're in the process of doing some experiments, and others have done some experiments. And so then you can take your model and validate it to an experimental setup. Obviously, it's much more smaller scale, but it's something, right? So you take these steps, small steps, where you say, okay, I've done 1D, I've looked at it, compared it to analysis solution, okay, check. And I've done 2D, compared it to analysis solution, check. And I do 3D, I'm going to compare it to an experimental. An experimental setup is smaller, but at least it's something that gives me confidence on my model, and the stuff that I put in it are correct. And you kind of build confidence in your model that way, step by step.
Have any of these models ever kind of come out being something you didn't expect, or maybe in the experiment version?
Yeah, absolutely. I mean, not even talking about the nuclear model, but other models that I've done, you're always questioning the results, because I always tell my students, you can model anything. Like, you can model gravity going upwards, right? Because the computer is not going to know. The computer's dumb. And so you need somebody checking those results and saying, does this make sense? I've put, and I've had several, it happens all the time, and that's what research is about, right? A student will come and say, these are my results, and da-da-da-da. And I'm like, does this make sense to you, that this result, I can't think of a very concrete example, but you're always questioning, and you're always asking yourself, does this make sense from what I know, from what I understand? And that's why, comparing it to analytical solutions or to experiments is invaluable, because you can model whatever you want it to, and without that check, it's not really useful.
What would you say are like some of the biggest problems in your field? So I know you kind of work on a few things, but what would you say are the biggest problems, and how do you see them kind of progressing?
I think in my line of work, the problems that we see is emergent contaminants. So when I was getting into the field, the biggest problem were what's called dense chlorinated solvents. And so these were chemicals that were used in manufacturing, and they were denser than water. And so if they were spilled onto the subsurface, they would sink. And it was really hard to find them and to remediate them. And so there was a lot of work done on that. And that's sort of now, it's still difficult to do, but it's much more well known and understood. But every decade or so, you get new contaminants that emerge. You know, you have microplastics, or you have perchlorates, or you have dioxins. So these are all different new contaminants that are released into the atmosphere, and now they're perhaps spilled onto the subsurface, and you have to learn how they move, what are their characteristics, and how we can remediate them. So it's this constant, oh, there's a new chemical that somebody has discovered that is really great for this application, but oh, it's not actually really great for the environment. And then it gets, spilled. What do you do? So you're constantly learning and trying to learn about the new compounds that are being released into the environment. So that's probably the biggest challenge, is there's always something new. There's also, a lot of changes in software. So computer models have come a long way. There's the addition of artificial intelligence now. So, some people are using neural networks to try to see how we can, we can augment our models and things like that. So yeah, there's lots of cool stuff happening.
So have you used AI yourself?
No, I have not.
Okay. Would you like to? Or is that a possibility?
Perhaps I work with a colleague that does a lot of that. So we, perhaps we'll collaborate one day. Yeah.
Yeah, that's cool. Do you see there being hope in terms of kind of moving towards a more sustainable future? Because that's, one of the biggest problems that we are facing now. So I know you work in soil remediation, which is kind of like a small field, but in terms of worldwide sustainability, how do you see it kind of going?
Yeah. Anyway, I'm hoping, that that's going to happen. I don't know. I think it becomes a question of whether people are willing to sacrifice certain things, right? Using a bunch of disposable things all the time. It's very easy and convenient, but it's not sustainable. I know a lot of people are going, and using reusable things, cups or bags or whatever, but not everybody. It's always a question of what are you willing to sacrifice, right? There's lots of new compounds and chemicals that are being developed that will ease and make things easier for us. But then there's the downside. So what are you willing to sacrifice? Are you willing to sacrifice the convenience to make things more sustainable? It's hard to have both, I think. And I think that's the biggest challenge I think that we face right now. And it's not easy. I'm not perfect, right? Like I don't use everything that could be sustainable for sure, because it's just convenient, right? So it's I get it, but I think that's going to be the next. It's difficult. I don't know is the question. I'm hoping that we're going to a better place. Like when, for example, when COVID hit, right? I was like, oh my God, it's going to be so great for the environment because nobody's going to travel, like planes, right, and cars. And for a while, like it was, there was. I think people said that air quality improved and things like that, right? Which was great. But then you saw this increase in plastic use because. I was afraid at the beginning to take my own bag to the grocery store because what if COVID hit? Would you get stuck on my grocery bag or something? So I would get reusable bags and just throw them out, and I probably knew better, but it's the fear. And so I know that plastic use and single-use plastic has increased because of COVID, because people are nervous and probably rightly so, but so I don't know.
Yeah, no, I agree with you as well. Like, there's only so much we can do, but we should always kind of strive to do better as a society. A little bit off topic now. So you're a woman doing an engineering job. So have you ever felt that being a minority in your field, or being a girl in physics or a woman in physics, has ever affected anything in like your career?
Not really. I've had really great support from my family, people I work with. I haven't really been affected too much. I think the challenge for women in engineering is less about sex. Well, I haven't experienced too much sexism in the workplace. So let's just be. I'm just talking from me. I'm sure I know it's up there, but personally, I haven't. There's been little things where you know, somebody once told me, oh, you just got this job because you're a woman, like little like snip remarks like that, and you're like, ugh, whatever, and you just ignore them. But so there's little things like that, maybe passive aggressive stuff that I have experienced, but nothing overly other than that. But I think the challenge is perhaps the family, raising a family, and also pursuing things like a career. It doesn't even have to be engineering. I mean, I know from my own experience, I'm a lot older than my male colleagues in the same position because I've had 2 children. And so I stopped my career for a bit. And that's, you know, that was my choice and I don't regret it. But sometimes it bothers me. I'm like, oh, I'm just, you know, I just feel older. And I'm like, and, you know, I'm a lot wiser. So
Yeah, you've got that age.
But sometimes, you know, sometimes it bothers me, and maybe it shouldn't, but there it is. And so I think that can happen a lot. I know that with COVID, a lot of females are now taking a step back and taking care of their kids and helping them with schools. And it tends to fall on the females, even in this day and age, and that is unfortunate. And so I think that's still a challenge. At least that's what I've seen. Not as much outward, like really big things like you could point to that and say that happened and that is sexism. That doesn't really, I haven't seen that. It's these little subtle passive aggressive little things like who's going to take the kid to the dentist. It's likely going to be a female, right? It's going to be the mother, and that takes away from the time at work, and that takes, you know, and that kind of slows your career down and stuff. So I think those are kind of the things we still need to work at.
So, I mean, do you have any solutions, do you think, or like maybe giving more paternal leave or making paternal leave more acceptable?
Absolutely. And that happens. I mean, I see that. I have a lot of colleagues, male colleagues, that have taken pat leave, and I'm like, that is awesome. Yeah. And just, you know, I think just a shift, a mind shift, that it's okay for a guy to be like, you know what, just a second, I've got a kid crying here. Like I'm gonna stop my work and I'm gonna go. And I think that it's just this shift of thinking that it's not always going to be the female that helps with those kind of things. But it's happening. It's definitely happening. I mean, it's happening in my household, right? Like we're very 50-50 kind of thing. And I see it with my students that they're just so much more open and they just get it. I think probably because they've been raised by females that are working, right? Whereas maybe my generation, that didn't happen. And so it's definitely, there's a shift for sure.
And so how competitive is the field? And do you think being a woman and being a minority maybe drives you more to be more competitive, to show yourself as I am good at what I do, so you want to be the best as well?
Yeah, maybe. I haven't thought about it that way. Perhaps. I think there is a certain part where you want to make sure that people take you seriously and that you actually know your stuff. I've had situations with some grad students that when they first start with me, male grad students, they almost question my knowledge and my ability, and that's frustrating because you have to prove yourself, and that shouldn't. I don't think men in my situation have to prove themselves, and so that's a bit frustrating. And so you're like, okay, that's so. But the competitiveness, yeah, perhaps. I don't know if I find myself in that situation where I find myself more competitive because because of my gender, but perhaps perhaps it happens, or maybe I haven't thought about it. It's a good question. I'm gonna think about that one.
But either way, yeah, it's good to be competitive in any field, like regardless of gender. So yeah, that's good.
Yeah.
So you were saying you were from Poland, is that right?
Yeah.
So you came from Poland to Canada. Did you feel the kind of family that you grew up in affected the career path that you took, or kind of the qualities that you have? Or that's something that drove you to engineering? I mean, you were saying about your dad as well, so.
Yeah. I definitely, I think so. Yeah, it's funny because I've thought about this question a lot because it's been, you know, it's always asked of me, and the question is, why don't more girls go into STEM? And a lot of people say, oh, because they're not encouraged, or it's stereotyped, whatever. I never grew up that way. Like my family never said to me, oh, engineering, that's not that's not really a girl thing. In fact, I remember when I would tell people in Canada, oh, I'm studying engineering, the first reaction mostly would be like, oh, engineering. Oh, that's interesting. And I know in the back of their head, it's like, oh, you're a woman and you're in engineering. That's interesting. Tell me more. It was always like, oh, that's cool. Whereas when I went to Poland to visit my family and I would tell them that, they were like, oh yeah. It wasn't cool and exciting. It was just like the norm. It was like, that's not a big deal. And I think that's the right approach. It's not a big deal that women are in engineering. It really isn't. Like, why would it be weird? Like, we're good at math and science.
Exactly.
we like to make like a change, and engineering allows you to do that. Like, why is this weird to you?
Yeah, no, I get
Sometimes
that.
I call people on it now that I'm older and wiser. But so that was a change. I feel like that was a difference between maybe North America and Europe or Poland. I don't know. I mean, again, my sample size is one. It's just me, so I can't generalize. But for me, that was different. I was never told, oh, you can't do that or you shouldn't do that. That's not a female thing. But I know that my friend who did engineering with me, she was in high school and she was always in my class and she was always good in math and science. And I know she enjoyed it. I'm like, oh, you should do engineering with me. And she's like, engineering? Oh, my guidance counselor told me that was too hard. My guidance counselor in high school. I'm like, come on. So I said, no, it's not too hard. You can do it. And she did. And she got her undergrad and her master's in engineering, and now she's a principal of a consulting company. Like, you know
That's
what
amazing.
I mean? Like,
yeah,
you get one person that tells you, oh, no, it's too hard. Like, I don't want to swear on video, but that just makes me so mad.
I think a lot of other females could relate to that, especially ones that want to go into maths or physics. So
Yeah.
So what would be the top 3 pieces or top piece of advice you would give into yourself back in high school or maybe just after you finished your degree?
I think not to be intimidated by others and to try new things. I think that, I'm talking here about like how girls are, just as good at science and math and all that stuff. But I did find that I wasn't as confident when it came to doing hands-on things, like doing labs. I was intimidated by the equipment, and I don't know if that's the same for all females, but I found that to be the case for me. Maybe it's because I wasn't exposed to it as a child, or I was afraid of breaking something. So I would tell myself, just just get in there and just do it. Try new things. I'm regretful that I didn't do things like Engineers Without Borders or go travel somewhere to use my engineering skills. I mean, I guess it's not too late, but if that's something you can do in undergrad, relatively easy, and I didn't, and so I think I would tell myself to do that. That would be a great experience, I think.
For someone that was feeling intimidated or not confident, what would you say to them, or how is there a way we could overcome that kind of feeling?
I think it's just practice. I think it's just throwing them in there and saying, no, you have to do this, right? Or maybe watching in a lab setting that the males aren't taking over and doing the stuff, because I have noticed that, when the girls are the note takers and they write the process and the procedure in a lab setting while the guys are doing the stuff. I think if you are in that kind of setting and you're a professor or a teaching instructor, you watch for that and you say, no, let's get everybody involved, and you're not going to be doing the writing. Like there's been times where I've gone into a meeting and people are like, oh, who's going to be taking notes? Magdalena? Nope. And I've had to say, no, I'm taking notes for myself. If you want to take notes for yourself, it's fine, but I'm not going to be your secretary. So it's little changes that people don't mean harm by it, but it's just a norm or something. I don't know.
But so there needs to be a change in attitude, right? Because obviously you say these are little things, but they can accumulate, right? And kind of be like, it's good that you've come to the place where you are and you've become really successful, but obviously these little things might affect somebody else in like a greater way. So I think there needs to be like an attitude change, system change. So yeah.
So more hands-on experience for students. I mean, both genders, but when you see an inequality of participation, I think you can step in and say, okay, everybody gets a chance to do this, right, and encourage that. some people say do an all female things. I think that's also a good idea. I think it does tend to be less intimidating for the females, but I also don't want to say that because then I feel like I'm not giving the females enough credit. Like why should they be intimidated? So
Yeah,
I don't know.
exactly.
I'm kind of on the fence with that. But for some, I think it might work better.
So I saw that you won the early career Hydrogeologist award. So how did that feel? That must have been like amazing.
Oh yeah, that was great. I think, I mean, it was an honor, but also I think it was really nice to be recognized by my peers, right? My colleagues put me forward as a nomination, and I think that was amazing. And I got to see the letters that they wrote, and I was like, you know, like I was touched. It was a great feeling, and really like, oh, like I'm being recognized for the stuff I've done, because it wasn't just about the research, but also, you know, I've done a lot of admin. When I started at York, it was a new school, and so that was part of I think the award, the fact that I helped with bringing the new school up and running, and I think the association saw that as well, and so it was a really nice feeling to be recognized. Absolutely.
What does success look like to you? Is it winning these big awards and getting recognized, or is it maybe something smaller, or maybe a collection of things?
A collection of things. I mean, I'd like to say that, oh no, it's all but it feels good to be recognized on a stage, right? Like I got to be honest, it does feel great, but that's not really success. That's the kind of the perks. What does success look like? I don't know, having something left behind that people like, oh, you know, Professor Krol or Magdalena Krol did, you know, was really good at X, Y, and Z. She, you know, she had this research that kind of led the way to something else. Also, the people you kind of leave behind, like my grad students, I think that having my grad students move on and be successful, getting jobs in fields that they want, is also great. For me, it's a great story. Coming from a family of immigrants, which is what we were when we came from Poland, I appreciate also having my students from other countries come. And I understand the challenges and the struggles they're going through. And so I know that, like, I had one student, my first student, she came from Iran. And after she graduated, I talked to her, and she was like, yeah, like I kind of gave up on coming to Canada or to leaving Iran because I wasn't able to get a position. And then I got your email, and we chatted, and I brought her to Canada, and she was great. She did a great job on her master's, and now she's working in a consulting company in Toronto. And for me, that's success, to have somebody who, you know, came from somewhere else, and now they're happy here, and they're making a life for themselves. And you know, I'll always have that connection with that person. And so that to me is invaluable. I think it's yeah.
That was really nice.
I like those kind of things. Yeah. So I guess yeah, the contacts you make, the people you interact with, and yeah.
Okay. That's all the questions I have.
Yeah.
But thank you so much for your time. Like, it was really insightful, and it was great to hear your story and what you think about different things. So yeah, thank you.
Thank you. That was great. Thank you for having me on this.